In this lesson, we'll review file I/O, specifically how to read and write characters and how to read and write bytes. When we work with files, we have to determine which of the Java I/O classes to use. Let's start off being byte-based, and in that case, we will use a file input stream for reading files and a file output stream for writing files. Again, if we were going to do random access, and by that I mean reading from a part of the file not from the beginning and not in order, but rather skipping into a different segment of the file, in those cases we would use the random access files, but we're not going to use random access files in the following examples. Let's examine this simple class that will read characters from a file. The first thing you notice is that we declare a variable called input. Input is of type input stream, and remember that is the superclass of all of the byte-based inputs. However, when we instantiate that variable, we initialize it with a new file input stream. And again, using the subclass is a way for us to be able to substitute different types of readers for the variable input. You then give the file input stream the file name, and now that's set up. Next, I'll declare a variable called data. Data is of type int. Remember that my read method for byte-based input is going to read everything as an int. All the work of this program is done inside this do-while loop. And we start off by assigning the value from input.read to our variable data. Input.read is going to grab the very first byte and assign it to the variable data. In the next line, we'll just print out our data, and then we'll just add a space so we can see exactly what is being read. And you can notice at the very bottom, you see the first line. The first thing that shows up is 66. 66 is the ASCII code for the character B. And then the next byte that it reads will have a value of 117. 117 corresponds to lowercase u, and then 116, that's lowercase t, etc. Now, remember that bytes will store values from 0 to 255, so no negative numbers. Now, the read method will do something special. It will return a -1 if there are no more bytes to be read. And the -1 is an invalid value for a byte. It signals to the read method that we're at the end of the file. So this is why our do-while loop has the condition of running as long as the data is not -1. When our do-while loop is finished, we print a blank line, and then we close the input. It is very important to close any file input or output streams that you open up. Number one, if you don't close these file input or output connections, you're leaving Java open to memory leaks. The other problem that you're doing is, to some extent, you're locking the file. The file is now claimed by this process, and it will not be able to be deleted or renamed, etc. So please always remember to close any file I/O class that you have opened up. Now, if we look below, we do the same thing again. We're going to reread the data. So we're going to reread the entire file. Remember that data runs in a stream, and once the data comes past, you can't get it again. So we have to actually reinitialize our input variable. We got to use a new file input stream. The other file input stream we created above has already done its thing, and we've already used the stream from the first byte to the last byte. So we have to start it all over again. And this time we're doing the same thing in a do-while loop, only this time, notice the one difference. We are casting. As we read in our bytes into our integer data, we will cast them as a character. And this is what gives rise to the second line of output, which again has read all the bytes, but it shows them as their actual characters. Okay, let's shift over from being byte-based to being character-based. So when we look at character-based file I/O, we're going to use the superclass, the abstract superclass of reader, and we'll instantiate it this time with a file reader. And we have a very similar loop like we saw in the last bit of code. This is a while loop, but it's still using the read method, and it's still looking for the -1, and then it prints out the characters. And you notice it's also doing the casting. As it reads a character before it prints it out, it casts it as a character. You may ask yourself, well, why is this character-based reader doing the same thing as the byte-based reader? And while it appears to be exactly similar, it's not. There's a key difference. When you are working with bytes, you know that you are dealing with an exact byte, and you read 1 byte at a time. But if you're working with characters, a character can be represented by 1 byte, by 2 bytes, by 3 bytes, even 4 bytes. So characters have something called an encoding. Think of a character in the kanji language, or think of some Arabic characters. Sometimes characters require more than 1 byte to store them. So while the byte readers read things a byte at a time, the character readers read things characters at a time. That means they might actually read 2 bytes of data for a 2-byte character. But regardless of whether you're character-based or file-based, the read method is still going to return an int. Also notice we have a few new methods. We have the very familiar read. We have our close method. We also have a ready method that tells us if the reader is ready to be read, if the file is ready to be read. And we have a skip method. And the skip method allows us to skip a character. So in this case, as I'm reading character by character, I can ask it to skip over a character. This will have the effect of reading every other character. So if we use a file reader to do character-based reading, we're going to use a file writer to use character-based writing. And when you make a file writer, again, just like our file reader, we will use polymorphism. We'll declare the variable writer to be of class writer, and we'll instantiate it with a new file writer. However, the thing to know about the file writer is there are 2 different constructors. Here you see the first one, which takes only 1 parameter for the file. Down below you see the 2 variations of the second constructor. This constructor takes a file name and a Boolean. Notice you can create a file writer and pass it the value of true, and if you pass it the value of true, you are going to append to the file. So as you open the file, if the file already exists, the characters you write will go at the end of the file. Or you could open it with the value of false, and that puts the file writer in overwrite mode, which means that any contents of the file that were already there will be wiped out and replaced by the new writing of characters. Now, I did this to show you how to use the second constructor, but in practice, I really don't want you to put in true and false. True and false means that someone who's unfamiliar with FileWriters has to figure out, am I in append mode or am I in overwrite mode? The best thing to do would be to declare a constant. Declare a constant of type Boolean and call the constant append mode. Set that to be equal to true. Make another constant called overwrite mode. Set that constant to be false. And then those constants can be used in this constructor instead of the actual Boolean values. In this way, it's great because our code becomes self-documenting. And so, with the FileWriter, instead of using the read method, you'll of course use the write method. What's nice about this is that the write method will let you put in a string, a full string, instead of individual characters. So this is how you would use the Java FileIO library to read and write from files. I will point out that this is not how you're going to do it for real. This is just an example to teach you how FileIO works. Normally, you would either read the file all at once, or you would read the file line by line. It's very rare that you would actually go to the trouble of reading character by character. And in future videos, we'll find out how to do other things.